As we begin our exploration of two-dimensional motion, we start with frames of reference. The key to understanding frames of reference is to be able to consider the perspective of each object or person involved in the situation. Because there are various motions involved, conventional direction becomes important. You must remember that the negative directions include south, left, and west, while the positive directions include north, right, and east. The sign is not always specifically stated, but the direction is, so you'll have to assign the signs. This definition of frame of reference says, a field of perspective of motion. Another way to look at it is, it's the point of view of the observer of a motion. Let's consider the following situation. The car is traveling west at 42 meters per second. The motorcycle is also traveling west, but at 57 meters per second. Both of these velocities are in the negative direction. It also states that there is a tree growing on the side of the road. Because the tree is considered to be stationary, the tree has absolute frame of reference. Let's consider this scenario. What is the velocity of the car from the frame of reference of the motorcycle? To calculate this mathematically, we consider that this is really a subtraction problem. We end with the object that is the frame of reference. So it says the velocity of the car. The car is going negative 42 meters per second. It says from the frame of reference of, that's minus, the motorcycle. The motorcycle also traveling in the negative direction, but at 57 meters per second. Now we just have to accomplish the math. The difference is positive 15. This means that for the motorcycle, the car is traveling to the right in the positive direction at a rate of 15 meters per second, seemingly going backwards. We can perform similar operations for every relationship in this scenario. We can assume, of course we could also prove mathematically, that the object to itself is the absolute frame of reference in each case. So we'll give those scenarios a 0. But let's consider the other relationships. Here we have the velocity of the motorcycle from the frame of reference of the car. Now the motorcycle is going faster, so it's going to pass the car and in the negative direction. So to the car, the motorcycle has a net velocity of negative 15 meters per second. The column on the left in blue are the frames of reference in each situation. We begin with the velocity of the first object minus the velocity of the frame of reference. Let's demonstrate a few more. The tree, which is going 0 meters per second, minus the west traveling car at 42 gives a net velocity of positive 42 meters per second, meaning that to the car, in the frame of reference of the car, the tree will be moving to the right at 42 meters per second. Just as the motorcycle seems to be going negative 15 to the car would appear to be going positive 15 to the motorcycle. Same magnitude, opposite directions, because of the opposite point of view. Just as the tree seemed to be moving to the right at 42 meters per second in the frame of reference of the car, the tree would appear to go 57 meters per second to the right from the frame of reference of the motorcycle. Again, the question would look like this on the next grid. What is the velocity of the car in the frame of reference of the tree? The car is going negative 42. minus the frame of reference of the tree, which is 0. The answer to this is negative 42 meters per second. From the frame of reference of the tree, the absolute frame of reference, the car appears to be moving left at 42 meters per second. And then lastly, for the motorcycle, the velocity of the motorcycle in relation to, or with respect to, the tree. So from the tree's point of view, the motorcycle will be traveling west at 57 meters per second. So all of the relationships between the three objects are all explained within this grid. The key to mastering the frames of reference are to keep track of the conventional direction. Is the direction positive or negative? Then to set it up as a mathematic sentence. Begin with the object whose velocity we desire to know, and end with the velocity of the object whose frame of reference we're using. And then following the correct mathematic operations should give you the correct answer in the correct direction. I hope this helps. Good luck.